Hello everyone, I am Sambarati. I'm decided to modeling a simple sample of explicit dynamic. Here is the explicit dynamic of ANSYS. We drag and drop the module in the desktop. Okay. In explicit dynamic, first we decided to choose materials. Here is a structural steel. But for better choosing, we choose this tab, explicit material. When you click on the explicit material, this menu has been changed. Look at there. You have some material which compatibility with explicit dynamic behavior. I choose aluminum 1100 or aluminum 1100. Putting add. When you click here to add the material, this icon appear here. I choose another one. I'm looking for a steel, for example. Yes. I use SS 3004 is suitable. Putting plus icon, and here is the booklet appears, and we choose two kind of material, this one and this one. I show in the future how can we use and define the material for each model. Put the cross here to close the window, and choosing geometry by clicking on the geometry icon. Okay, we entered the geometry environment. I don't try for modeling in the ANSYS. I using to import the solid material as IGS format. Putting the file tab, import external geometry file. I use this one, a kind of model. The model has been imported, but we use the generate icon for generating the model in the ANSYS software. It may be sometimes if your model is complicated, it takes more time for importing and generating the model in ANSYS. It depending how your model is complicated. Okay, here we have the model. You can see the part, each part, shaft, forward shaft, back right wheel, back left wheel, the main body of the vehicle, or actually automobile, and the others. But we decided to choose all the parts as a unit model. So I put the control key in my keyboard and choosing all of the options here. When you choose all the options, right click on the highlighted and choose from new part list. Look at this. All the parts of model gain together here as a unit part. After that, I decided to model another here. An object who decided to put the automobile as a crash accident. So I decided maybe rectangular is suitable. I think so. I drag here, release the mouse click, extrude this one, but the height of the rectangular can define here. I choose the 0.05 and generate. Look at this. It's about 50 centimeter here, and add another part here. Okay, When you model two kind of model in ANSYS geometry, the object that you want and try for crash the option, I close the geometry window and click on model. As I said in defining material, I said in the future I say you how can you define the model and materials of them. Here we can decide what kind of material is belong to which model. Over here I find the model, this one. We can defining assignment here, put aluminum 1100 for all the bodies. Even you can choose one by one for defining here. Okay, and of course the object here I choosing for SS304. We defining the materials of both options here. After that I prefer two kind of essential and of course important behavior in ANSYS. Look at their connections. We have connections. Which connections? We decided that here this one and this one can be contact even in the future when you try to analyze them. This one, look at there are two windows who decided which part is the contact body and which one is target. You can defining here contact and target, and this is the second one. Look at there, as I said, this surface and this flat surface of the option here you can defining as contact and target. It's so important when you're using bearing on in other analysis too, but I'm not here for describing the connections. I'm here for preparing and studying a simple method of explicit dynamic. Okay, I pass this option and try for getting a simple generate mesh. It takes sometimes a more time if your model is so big and your the mesh is so small. It maybe take so long time, so I prefer for pausing the recording, and after it's finishing I resume the recording too. Okay, it's almost done. It seems not. Okay, here it is. All two options or actually are two part of models had been meshed. We can see that this part as a cubic, as a regular cubic mesh or a square mesh, and this one because of so many curves in the body using the triangle meshes. If you need to choose the or actually specify precisely meshes, you can use right click here, insert or some kind of meshes as you like for each part of the model. Okay, let's keep going. Here is initial condition. You can defining the initial condition if as you want. For example, a pre-stress is here, defining each kind of you want. You can right click, insert velocity for each one as a initial condition, but be careful for having the difference between this velocity and of course this velocity. There are some differences between them and we want to use this one. I choosing right click, insert fixed support. For this one I putting the control key and using two faces for this model and clicking apply. You can see two surface, apply the fixed support, and you can see the fixed support here. Okay, I right click again using the velocity for this one, but this one you must to choose all of them and it's difficult for choosing each one, and by changing my selection object as a box, I'm changing my direction by putting the scroll of mouse here. You can see that many of surfaces and including this one in selected. I selected again. Oh sorry, in this one I use single and it's better. Okay, you can see that some parts are using control for defining the other elements, but you can see even here some kind of surfaces didn't chosen. So I click here, changing my selected bus. Okay, and of course choosing the control but deselected both. We have some problem because of the complicated model, and yes, here we are. Yes, it is. It's done. I apply. Okay, look at this axis. We have x-axis here, but we need the automobile walking through the inverse of the axis. So I choosing x-axis here. I'm putting minus for getting inverse axis here. Look at there. Yes, it is. And about 500 millimeters per second is suitable. It means about 5 meter. Let me increasing this. Yes, it's about 5 meters per second. I think that it's not suitable and changing for 50,000 millimeters per second. Here there are a question mark here. It means that there are some objects who didn't define completely for analysis. I clicking here for determining which part of didn't define. You can see this yellow bar here. It means that the end time you must to choose how much or how long this behavior is happened. I put about 5 seconds. I think it's suitable. And okay, it's done. Here is an important option: maximum number of cycles. It means that when the progress is when the analysis is in progress, you see I showed that how the ANSYS software is simulating and calculating the behavior. I changing this one to up about, I think that 3000 is suitable, and I show in the about some minutes in the future how can it solve. I putting the solve, but I right click the formation total deformation, right click, stress, eigenvalue of von Mises. Many of scientists say that it's von Mises, but it's wrong because von Mises is a German language. It's the correct is von Mises. I putting solve, and of course showing you, clicking by simulation information for showing you the cycle as I said here. Okay, it's a starter. Yes, look at the cycles. I defined 3000 and it's started for 3000 time for calculating. It means that the duration and cycle, there are two different defining, and the engineers must pay attention about this time. Okay, it takes so long, but how long? It depends the cycles you define, the complicated of the model, and of course the speed of the model, and of course the duration that we defined about 2 seconds for this. All these behaviors and options and of course parameters defining the duration of progressing is done by the ANSYS software. And I see here a Windows, it's not actually a kind of error, it's depending about your graphic and hardware and belong to your hardware of your computer or laptop. I closing this one, and it takes so long. I'm pausing the recording, and after it's finishing I resume the recording again. Okay, here we are. You can look at the time. It's about half hour past and it's still progressing. I change it to worksheet tab. We can see the cycle number is 2080-70 and it's keep going. We define to up I think 3000 and to be continue. We can see that it's still working and take so many time. We advise the cycle means the sequence that happening. It's just like that the camera with more frame per second that can taking picture or taking movie. Yes, it's almost finished. 2000 941 and it's about 36 seconds remain. You can see the sorting time here, clock time remaining. Yes, of course it's about 30 seconds remain. When it's finished, if all the options here in the analysis tree had been the green tick like that, just like that, all behaviors is correct. But the engineers must be investigate the data which earning from the finite element software and analyzes the data. Yes, it's finished. Okay, I changing the graphic here. This one you can see the maximum as megapascal unit, total deformation here. Okay, I changing the animation as a movie. You can see what happened here for it. We can the movement, but the speed is so low to crashing, so I preferring to stop the framing, changing the analysis actually to 100 for checking, and the velocity, putting 10 for increasing the velocity and getting solved. It makes so small time for analyzing because I'm changing the cycle number from 3000 to 100, and you can see the overall progress tabular is completely visible for improving and passing. Because of so many slowly the vehicle, during 5 minutes that we define, no crashing between the model and object happened. So I decided to increasing the velocity, to checking again the investigating of the explicit dynamics. It may be happen for all people that working with explicit dynamic, and it's a good example for those people who decided for starting with this module of ANSYS software. Yes, let's see the simulation. Yes, 90 and up to 100, and after that it's finished and close the cycle loop. Yes, here it is. It's closed the window automatically. Yes, overall progressing is done. I'm preferring the total what happened for it, playing the movie what happened for this crash. Is it? Yes, crash happened, but it's not enough for collapsing the deforming equal stress. Let's see this one. It's taking one. Yes, okay. And here we can increasing the velocity, solving again. It makes so time. As the progress is starting, I'm pausing the recording. Okay, the progress is finished right now. It takes some long time too. If I click in total deformation, I see that how is changing between this part and this part. You can see that the steel beam is completely stiffed and the automobile is crashed here. Let us see what happened as a movie. I increasing the frames and increasing the time, and after that I play it. Let's see what happened. Okay. As it's progress, let me explain more. We have here a diagram, actually in coordinate system. Vertical axis is millimeter because total deformation is present, and horizontal axis is s, which means time, deformation per time, and here this table is, yes, this is started, time, minimum and maximum of deformation. Yes, it is. It's changing as a unit because all these we consider the part time. What about the evaluation stress? Increasing frame started here. Yes, excuse me. As we can see, here is the coordinate system with megapascal and time. Yes, but maybe some question appear here. Why is it stopped? Because we define the analysis for just 5 seconds. If you changing the 5 and increasing the time, you can see the crashing more. Maybe it's the vehicle input inside the beam here. That's all. But if you want to understanding and trying more, there are some kind of notations that you can consider about that. For example, the connection here. We decided and explained sometimes before. What happened if you neglect or suppress this? What happened? There are some these questions, and if you have any question, I'm here for answer. You can see me in the LinkedIn website. You can send me in as a mail. I type my mail here to sambarati@gmail.com. This is my mail, and for website LinkedIn, this is my ID Sambarati. You can search me in LinkedIn engine, and if you have any question, I'm here. Feel cool and ask. Thanks for consideration too. So goodbye.